Hello, Honors Chemistry, and welcome to 7.7 Net Ionic Equations, where, if you take a look here, you'll see that all we have is, lo and behold, a precipitation reaction, right? Because here is our precipitate, which means that all we're doing is we're just adding a layer to what we did last time, right? So last time we talked about how we could look at two ionic compounds, assess that this was a precipitation reaction, or potentially a precipitation reaction. We would figure out what our cations were, switch them, figure out what our two new products were, apply our solubility rules, and see if indeed something precipitates, right? Now, in terms of writing our precipitation reactions, right, obviously if this KNO3 is still aqueous, right, what that means is we still have K ions, right, and we still have nitrate ions just floating around in the solution, right? Which means that they remain unchanged, right? And a net ionic is just something that allows us to better describe what happens in a precipitation reaction, right? Or any reaction, actually, right? And we think about what net means, right? Net is like your net savings or your net paycheck for those of you that have jobs, right? That's the amount that you get at the end, right? After everything else is taken into account. Right? So let's go ahead and we'll run through this one as a practice, and then we'll do that skill builder together, right? So this equation here would be called our complete molecular, where it is all of our compounds written out with their complete correct formulas and balanced, okay? Now we are going to go ahead and take a moment and figure out how to write the complete ionic, right? We're going to have to ask ourselves a couple of questions, right? Is it ionic, and is it aqueous? Yes? Is it ionic, and is it aqueous? If it is ionic and aqueous, so ionic and aqueous, right, means that we're going to dissociate it, okay? So here, ionic, aqueous, we're going to dissociate it, right? If I have two Ki's, what that means is I have two K's and I have two I's, yes? We also have this, which is ionic, aqueous, so we're going to dissociate that, right? So I have lead. And again, you could work backwards to figure out the charge based on the fact that there are two of these nitrates. We have two nitrates. Okay, and then on my product side, I have ionic but solid, right? It does not meet both criteria, therefore it does not get dissociated, and we'll just write this as it is. And then we have ionic and aqueous, so this also gets written as its respective, oh, I forgot to put a 2 here. So 2 K plus and 2 nitrates. All right, so now we have our complete ionic, yes? Complete ionic, that's what I mean that to be. All right, now, how do I get from the complete ionic to the net ionic? Right, in order to get from complete to net, I'm going to cross out all of these spectator ions. Yes, we're going to cross out all these spectator ions, which are the species that are exactly the same on both sides, right? We're going to cross out all the species exactly the same on both sides. So here, exactly the same, cross that out. Here, oh, on the product side, there are no iodide ions that are aqueous, so we leave that. Lead, nitrate, yep, that gets crossed out, which means that these make up my net ionic. So then I would have 2I minus aqueous plus lead aqueous gives us PbI2 solid. And this would be our net, yes? Wherein that is what actually changes during the course of the reaction, right? And if we think about what that means, right, these don't change, right? This stays the same, right? This stays the same. Does that make sense? As in there are potassium ions floating before, there are potassium ions floating around after. No net change there. And that would be our final answer. So then to do another practice one, this is your skill builder. So we're given this balanced equation. So we have our complete molecular. Now we're going to whittle it down. So first we're going to apply those conditions again, right? So it needs to be ionic and aqueous to get dissociated. Acids are a bit of a special case in that we treat them as ionic, and so we're going to apply the same principle here. We'll include that with our list of ionics, right? So we have 2 H plus aqueous, and 2 Br minus aqueous. All right, we have ionic aqueous, right? So we have calcium 2 plus aqueous, and 2 hydroxide ions aqueous. And then on my product side, it says that I have water, which is a liquid, yes? So water, not ionic. It's also not aqueous, right? So it doesn't meet the criteria. So we're just going to write that as it is, right? And here we have ionic and aqueous. So ionic means Ca2 plus and 2 Br minus aqueous, right? Now, just like last time, we'll go through and cancel the things that are exactly the same on both sides. So we have those are the same on both sides. These are the same on both sides, right? Which means that this becomes my net, yes? So I have 2H plus aqueous plus 2OH minus aqueous gives us 2H2O liquid, yes? As in, that is the only thing that changes. The thing that makes this unique, right, is that water is clear and colorless, as opposed to like a precipitate, which would form an obvious solid. So your eyes won't perceive, right, that something has changed, but our reaction and other criteria, right, like, so for example, if we have an acid and a base, our pH, right, going back to things you learned in middle school, would be something that could tell us, oh, a net reaction has happened here, okay? What else was I going to say? Oh, and finally, here, when we get down here, you are welcome to reduce if you would like, right, if it is reducible, or you can just leave it with the coefficients that you derived from your complete molecular. I don't care. It's fine either way. Okay? All right, so that is a complete ionic. If as you practice you find that, oh, you don't need to do that complete ionic step, and you can visualize how to get from your complete molecular here directly, that's fine. Unless you're prompted to provide the complete ionic, you don't have to do that intermediate step if you don't feel like you need it. All right? All right. Thank you for listening. Be good and stay tuned for the next one. All right. Bye.